Okay, folks, welcome. You are at session 2 for the MuleSoft Certified Developer Exam Prep. And today we are going to be going over the next part of our process here is going over the design fundamentals and the life cycle of the API. So I'm going to share with you the life cycle of an API. Let me begin with this. With the life cycle of an API, let's say we've searched to see if we can find an API that will work for us, either in a repository or on Exchange, and there's not anything that we can utilize. So what we end up doing is creating a specification. And this is the first part of the life cycle of an API. And in our case, we are going to, showcase RAML. However, OAS or OpenAPI spec, which is formerly known as Swagger, is also another language that can be used for specifications. These are all created in API Designer. Another option is creating your specifications in Anypoint Code Builder. Now, Anypoint Code Builder is another option for developing not only your specifications, but also your Mule applications. It will not be part of this exam at this time because it's not officially been transitioned over. So really everything that you will see on the exam at this time should be Studio. So anyway, so we will start off in reviewing details in Design Center. And this is all part of where we design out our specification and provide example data. And that example data is what the mocking service will use in the API console, even in Design Center. Notice the API console is shown on the right-hand side in Designer. So terminology for the exam, API console. And the API console, in this case, is using the mocking service. And the mocking service uses the example data that we provided in our specification. Okay, so the next portion, once we're happy with our design, now there is a way to open up an endpoint in Design Center to share with any stakeholders who are not a member of the Anypoint platform account. Even in Design Center, we can share that endpoint. Now, once we're happy with what we are seeing in Design Center, then we'll publish it to Exchange. Now, Exchange is another place where we can share our API design and get feedback from either team members, or we can also share it in the public portal of Exchange and then share it with any stakeholders or individuals that are not on our Anypoint platform account. So when we publish it to Exchange, an API portal is created. And in session 1, you saw me go to Athena Health's developer site, and we could see it was kind of like a portal to see what those APIs, what the specifications were basically, like what was needed on a request, what we were getting on a response. So this is where we will have that information available in an API portal. Again, terminology. Remember, API console is where we actually click and test out our resources and our methods and are able to get the mocked service results from our examples. The API portal is the entire page in Exchange. Okay, again, terminology. Make sure you have that terminology. And when we first publish our API to Exchange, it's in a private Exchange, internal to our Anypoint platform team. Anyone that's on our Anypoint platform account are the only ones that can see that until we share it on the public portal that's that is shared publicly, and there is a public portal version of Exchange. And you can control what is shown there or not. You can choose to share it publicly or not. You can, so there's that ability. All right. So, as you go through this iteration, we have brought it to the point of where feedback we can get feedback on our design. What if in our data types something needed to be modified, early on before we've moved forward into creating a full-blown application? This is just at the early stages of capturing the data type, some example data of what that will look like. And, our stakeholders or other team members can look at this and say, this is great, or we need to modify this. We need, instead of this particular date, we need a date time, or maybe it's, the other direction, so whatever the case may be of whatever modifications have to happen, you're getting that feedback early. That's why we always say design first. Design first. We're going to get requirements from the client as we interact with them. And once we know what those requirements are, we start building out this design. So that's where, we're at on the iteration here. Now there is a validate as well. And what's going to pop up here is something called the API notebook. It is a way to test out code. I am not sure if you're going to see anything about this on the exam, because at one time this feature was actually queued up to be deprecated. They kept it on. It's still here. So on your API portal, and you go in to add your documentation for your API, there is the API notebook still existing there. But again, I don't know if there is going to be anything on the exam on that. Okay, so this is the first iteration right here, first iteration. Now let's go to the next iteration. Let's say that this part is done. We have a published API and Exchange. We're happy. Now what we do is the next iteration, and this is where we build out our web service with our API. In other words, our Mule application. And we use our Mule application, or I should say, we use our specification to bring it into Studio to create our interface. Okay, now there's different naming conventions for this that you can name your XML file, but it is your specification. It is generated through the API Kit router to generate your, not only the main flow that you're seeing pictured here, where all of the requests will be coming in, but also a flow down below. This is a private flow for every method resource pair. For example, patients get by ID, or patient's ID get. So every method resource pair has a flow. You will need to know that. That is something relevant to the exam. Okay. So whatever you've got in your specifications, let me grab a specification here. And in here, here's my patient API. Let me run to, here we go. Oh, well, sorry. It timed out. I was prepared though, see?
I'm glad you're showing an example of that. I'm pretty sure I'm clear on that, but just so that way I can kind of see it and visually memorize that.
Yeah, that's good. That's good. I'm going to also bring up Studio so we can see the other result on that side.
Perfect.
Yeah, because there, if I recall, there could potentially be a question with how many flows are generated, based on a given specification.
Right.
And so we want to make sure we're clear on that.
Good deal.
Yep.
I'm taking notes, not backing up, keep moving forward, but looking at my notes, one way I've memorized that the portal is going to have to do with Exchange is because you don't get that portal until you go to Exchange. And then the console is, where you design and
Right.
Makes sense to, it just kind of cleared it up in my head when I was looking at that in the curriculum.
Yes, yes. So
Good.
you have that console here.
Mm-hmm.
You also will have it when you go to Exchange. So I'm
Right.
glad you mentioned that. That reminded me to show in Exchange. Well, look at this. We're getting busy out here. That's good. I need my RAM open. Here we go. Okay. So we also will have what this is considered to be like an area of an API console in Exchange as well.
Right.
Yeah. So even though this is an Exchange, is considered to be an API console area of the entire portal. So the whole page is a portal. And then
Right.
this one is your console area too, to click and then go into the different requests here. So, oh, and let me show you too while I'm here, is in the edit documentation, you can, there's the ability to add additional pages, and this icon here is the API notebook. I'm not going to demo it. I'm not going to go into details with it. It's just there. I have used it a couple times, never professionally, but it might be a good way to show how certain things work,
Okay.
but so in the process that we're talking about, once this portion is done, then we go to Studio and we populate this or import it, I guess you could say, into Studio. So we have our main flow here. And then we also have the console flow. And then for every method resource pair, and there are 5 of them, we can see we have 5 of them. Okay, these are all your method resource pairs. You get patients, post patients, get patient by ID, update patient by ID or patch, and delete. So all of these, there should be 5 flows present in Studio. And there are 1, 2, 3, 4, and 5. 5 private flows. Now, they're private flows because there's not a source on this side. There's no listener or anything there, but the API kit router auto-generates every bit of this. So in this iteration, you start off with your specification. And the beauty of using the API kit router is that we also get this host of error handling built by default. Okay, so all of this is available by default for you. And the listener, you're going to hear us talking about the listener, and the listener has like a prefix wildcard here for every request coming in. So when we send in a request, we have to include this API prefix and then whatever path we want to go to, like patients, and then it's a GET request. So that will route us down. It would come into the API kit router, route us down to the GET patient flows, GET patients flow. So then the next step is to build out the functionality of what this application needs to do. And so what this application needs to do is actually get the data. If we were to just leave it as it is, it's only going to serve example data. And we don't want that. What we want to do is we actually want to get live data from the database. Hence, when we come down to the get patients, we want to flow reference over to really getting patients from the database. So this is connecting to a live database by way of our configuration files, details here that were populated in through our global element that we set for that database. So again, a lot of this is a result of configurations. Now we'll talk about structure in the next portion of this discussion today. So I'll go through some of that in more detail. But most importantly, for you to see that the interface or our API specification that we created is used as our design of how we're communicating with a client. You have to have a certain method to hit, like, and you have to abide by the regulations that are set in our specification. And then there would actually be more flows over here. This one's not completely built out, but then we would complete out all of the flows here and finish our design of our web service, as it's mentioned here, or often you'll hear us say the Mule application. And we'll test it out with Advanced REST Client and make sure all of the endpoints are working as they should. And this iteration is where we go through and, test out our Mule app locally. Locally, it's running in a Mule runtime on our system. And we can see that when we deploy it. We see the build is done first, and then a JVM is spun up, the Mule runtime is installed in there, and then our application is deployed within that Mule runtime. So we're actually running it locally on our systems, and then using Advanced REST Client or Postman is another option to interact with our endpoint, okay, the different endpoints that we have in our application. So in that case, because we're running it locally, we would be using the local host. That local host :8081 is the correct host name to reach our application in Studio. Okay, so it would be http://. I'm trying to load it here to bring it in, so it's taking its time. There we go. Okay, so in the case of the application we're talking about right now, the URL would be API. Remember, we have to have that prefix because we're using the API kit router, and that's for any of them. And then we'll do patients to hit the get patients method resource pair. Okay, and then if I want to do get patients by a certain ID, I could do the get patients and it would bring back a single record. I could also do the delete. There's the other endpoint. I could use the patch, another endpoint. I'd have to declare the body of what I'm sending in, and also to the post. Likewise, I'd have to send in the details there. So it's not running and I don't have all of that up, but I just wanted to review the method resource pairs from our specification that are now available in this application as a result of our API kit router building those flows out. We build out that backend logic also with the database interaction, and then we're good to go. Once we have our application fully functional, we're satisfied with the results, then our next iteration comes. And this next iteration is where we deploy it to a runtime somewhere. Okay. And the runtime in our case, and really for the scope of this exam, is we use Cloud Hub, but there are other deployment environments like a customer hosted server. Okay. So we could have our servers running on our system, and those servers would be supportive of us deploying our apps to them. Another one is also Runtime Fabric. That is also another customer hosted environment. And what the customer does in those cases is spin up their own Kubernetes, their pods, and they have a complete different network structure. So we would also deploy into Runtime Fabric that is managed through that Kubernetes technology or Kubernetes environment. So in our case, we, for all of the classes walkthroughs, we pretty much use Cloud Hub, which means that our application is deployed in a container. If you're deploying to Cloud Hub 1, it's in an EC2 instance on AWS within the Cloud Hub 1 environment in the cloud. And in that container is a runtime and your application. But it's containerized, it's isolated, and so it's individually deployed in Cloud Hub 1. And Cloud Hub 2 uses under the underlying technology under Cloud Hub 2, which is what we pretty much are using now, is Kubernetes. So it's deployed into a pod, and that pod in turn is going to have a runtime and also to your application. So it also is containerized. Okay. So we deployed them, our application. And now there's something important to stress here that is very exam relevant is we can deploy directly from Studio. Okay. Deploy to Cloud Hub. We can do that. But, and that's one way to deploy, directly from there. But in most cases, when we're using a pipeline for deployment, what happens is our source code is taken and Maven builds out a deployable archive, okay? And then takes it and deploys it into using the runtime manager into Cloud Hub or on your servers or in Runtime Fabric. So what happens is we need a deployable archive to do this. Now, this is a great view, and this is exam relevant. If you export your application, okay, so if we go through to export, you can go into the export process and click on the Mule folder. And of course, there's only one there for Anypoint Studio Project 2 Mule Deployable Archive. We'll go to next. And this is really important here. Let me make sure this is going to go someplace easy to find. You can navigate where this is going to end up. I'm going to go ahead and get it on my desktop so we can find it really easy. Okay. And so the options here for you to choose are to include project modules and dependencies. And you'll notice here that says a lightweight package generated without the modules and dependencies won't be deployable to Cloud Hub. So if you do not include these project modules and dependencies, this jar file would not be able to be used to deploy either through a pipeline or in the runtime manager. Okay. So I'm going to go ahead and export this and show you what this one looks like. So we'll click finish and it's exporting. Let me grab it over here and show you the difference between. Okay, so that one has completed. All right, and now I'm going to go through that same process again to export this. But this time I'm going to unselect include project modules and dependencies. And then I'm going to add to the end of this -LITE for light. That is a light version of this. Okay. And I'll click finish. Okay. But what that light version can be used for is if I wanted to pull a jar file and share it with somebody really easily, I can do that in such a way that I am, it's a lot smaller. Wait till you see the difference here. All right. So here we have the difference. This is the full jar file. It's 69 megabytes. That includes the modules and dependencies. It's a package deployable archive. The light version is 43 kilobytes. I could send that over to you easily, and it's easy, it does not have the modules and dependencies. And it's mostly used for me to pass to maybe another version of Studio, or someone else might be working on it, and I can say, hey, go grab this and import this. And when you import the packaged Mule application in the light version, and you go through this process, what it will do is add the modules and dependencies back to it from your Studio. So it's got a purpose. There's clearly a purpose with it. But what you cannot use that light version for is in Anypoint platform when we're interacting with the runtime manager here, or if we're doing that doing automation. If we're automating it through a pipeline, it has to be a deployable archive. And that would be where I would come in here and I would click deploy application and choose a file. If you upload this file, it must be a deployable archive. If it's not a deployable archive, it will fail. It will fail. Okay. So that's the importance, and that is very exam relevant. Okay. Very exam relevant on the difference between, what is it going to take when you are at this point. Okay. Include the project modules and dependencies, then it's a deployable archive, not lighter version. Can't deploy it, but can populate it into Cloud Hub or into Studio. You can, use it in Studio. All right. So wanted to be very clear on that. Okay.
Do they even show you a picture of that very window, just out of curiosity, like curious what we're in for here?
I want to say, I can't swear to it. Somebody who's taken the exam recently needs to chime in. It's been
I was just
about
wondering if they
a
worded
year.
up.
Yeah, they very well could.
Okay.
Because there are a lot of, what do they call them in the exam? Exhibits.
Right.
Look at the exhibit and see what this would generate, or something like that.
Gotcha.
I don't know.
Makes sense. Okay. Good deal. I'm clear on that. Yeah, I remember you showed me that a while back. So I was good on that. Very good to see it again.
All right. So we have the runtime manager where we're going to deploy our application to. So it gets in Cloud Hub. And remember what happens when we deploy it to Cloud Hub. So let me grab one of these that's already there. And there we go. Okay. And we get this application URL. So this is a public endpoint. And we find out that it's wide open. Anybody can access it. So we need to secure it. We need to manage it with API Manager. And that's where we take and manage our API from API Manager so that we can secure this. Like I said, it's wide open to the world. So we in turn come now to API Manager, and we take and we manage this API. Okay, we manage it. And just the beginning part of managing it involves us going through the process of choosing the type of management that we want. Let me go back to that and show you what I'm getting at here. Adding a new API in the Mule Gateway. Now, our focus for the MCD one is going to be the Mule Gateway. You will not have, I don't think, there's no curriculum using the Flex Gateway, which is another great tool, but our primary focus will be on the Mule Gateway. And you have two options for the type of enforcement, where you want your enforcement to live. You can either use the existing basic endpoint, or you can use a proxy application. All of our course material, including whether it's Salesforce or integration class material, is the deploy a proxy application. Now I've got documentation already on both kinds and how you will do both of them. Now for the exam, you just need to know that they exist. You don't have to know exactly how they all have to be built as far as that's concerned. So, but I will have, and I do have already, and we'll share that with you all, the different, how to do both of them, because there's reasons that you would choose one versus the other. In fact, in most cases, you would probably use the basic endpoint. So we manage through API Manager. And as we manage that through API Manager, at first, when you first start managing it, it's only managed. There's no policies or anything added at the very beginning. So it's still wide open. Okay. In API Manager, yeah. At first, it's still unsecure until you add policies to it. And once we add policies, and there are a host of out-of-the-box policies available for you to manage it in different categories. These are the security policies. Okay. And it's good to know what the policies are. Depth of details for each policy is not necessary for this exam. Architect exam, yes, but it is good to know what they are, what they do, high level. Okay, so if you have questions surrounding that, we can go deeper. Quality of service, we have some rate limiting, in other words, limiting the number of requests for a period of time. And then we have also client ID enforcement, cross-origin resource sharing and through different domains for compliance, and then transformation of header injection, header removal, as well as troubleshooting and adding additional logging that you can add. So in the rate limiting SLA based, it's a combination of the rate limiting and the client ID enforcement. So you're going to see a combination of both being used here. And it's kind of like, where we will add our SLA tiers, our service level agreement tiers. Like we are in this one. This one has a, if you add an SLA tier, you can name it and tell the number of requests per a particular time frame there. And that is part of the policy for the rate limiting SLA based, because then that is in turn where you can use that. So we would add the policies and in turn secure it. That's the secure with a policy portion, okay, of certain policies. And as a result, too, we have monitoring. So there's Anypoint monitoring. We can have analytics, visualizer. All of these features are part of supporting the lifecycle, the API lifecycle in its fullness between Anypoint monitoring, analytics, and visualizer. So we can set alerts if there are policy violations. We can set alerts if our CPU in our pod becomes over, at a high threshold. So we can do quite a bit in each of these categories too. I'm not going to go into these areas on the platform right now. There'll be more that I share there, but for the sake of kind of keeping on track with what we're doing here, it's pretty much high level of the life cycle of the API. Okay, any questions so far?
No, that's really clear. I'm recognizing everything there.
Okay.
Good to see it.
All right. And if anybody watching the video later has any questions, just let me know or go ahead and post them below the video. We'll be glad to come back around and check that out. Okay, so this is, again, just a overview level of the life cycle of the API. And that's where we wanted to really, have that focus as we enter into drilling down into that first iteration. And so in our RAML, our focus will be on RAML for right now. RAML, the abbreviation is the RESTful API modeling language. Okay, so RESTful API is a type of API, and it uses the RESTful API standards. And I have a good, where is that? Let me bring up something I found recently that I thought was a really good document. 1 second here. And I will share this out also, the link on this one. Yep, here we go. HTTP methods in MuleSoft. So I thought he did a really good job on this. Let me put the URL for this in the chat. So just a really good overview of HTTP methods. And it talks about, different ways you can, the different tools that he uses, including Anypoint Studio, curl command line tool for interacting with your URLs. That's a good one to know also. Postman, the one that I mentioned, and Advanced REST Client. So he'll go into details of creating a project, defining the flow. And I found that, even in the Mule message, he's got some good points here. But then coming down to what are HTTP methods? And this is where we can interact with an endpoint and, of course, get data, post data, various needs based on our requirements. And he goes into details between the post, which is what we commonly use, the put, also the delete, and the patch. So you will need to know. It also talks a little bit about header, about the head method, the options, and trace. So I thought this would be good for you to review. I do recommend just being familiar with the different methods. Okay. Make sure you're clear on the difference between the put and the patch. The get, the post, and delete are going to be pretty, easy to remember. But I want you, to have had that also. So that's a good reference on the different methods. And then we get into the different parameters, attributes, responses. And so let's take a look at, we just finished a video that we're documenting that goes over the difference between the URI parameter and the query parameters. So we'll share that with you. I'm going to go high level here, but we've got some other documentation coming forward on that that's really helpful also to really grasp the difference on that. So first, many of you are experienced in RAML. On the left side, we have our file structure, center areas, canvas, and then this is our API console on the right. We can open this up to a public endpoint and share it publicly with stakeholders to let them see what it looks like even in Design Center. That's here by turning on this slide bar here. You have a public URL here. Okay, that's where it's at. And then in our RAML specifications, we in turn, in this case, use our a patient fragment. We're bringing that fragment in through here as a type, and we define it with a key name of whatever we want to call it, and we pull this fragment in from Exchange. In our case, this fragment, we chose to publish it to Exchange as a reusable asset for other team members that need to use that data type can freely bring it into their specification. So that is the purpose and the benefit of reusability, because where this really benefits is in the data modeling. So if we look at what this RAML looks like, this fragment, notice you're read only, and that's because it's published to Exchange. If this needs to be modified, the person who manages this fragment is going to be the one that can only change it. The owner of that fragment is the one who can change it, which means it's setting a standard. This is kind of like controlling the data type field names and the data type itself. So someone can't just come in here and make modifications. Well, that might impact other specifications. So you want to, this is a great way, as far as architects are concerned, to manage your data types across an organization. But if I decided like I needed to add additional fields to this, I can't add it here. but I could add it here. When I'm referencing patients here, I could add additional fields here if I wanted to. Like say there's some other things I needed to add, I could. Okay. So it gives you that flexibility to do that. We would use the basic one that's there already, but we could add additional fields. So as I was mentioning, we're going to look at here's the endpoint for patients. There is the method, as you know. Now, these are just display names for documentation, and you'll see some of those popping up in different places. But the query parameters are defined here. Okay, so we can define the query parameters in our GET request. And as we define them, notice that the examples in this case, and even the type that it is, are what we refer to as inline. We have added the type that it is and the example inline in our code. Now, the reason we don't do that for everything, because we've got patient example here. We've got patient no ID example, additional things. And the reason that we don't add all of those examples in line is because we might reuse them in different places of our code, and we don't necessarily want to list it numerous times. That's not reusing code. These examples could be an Exchange. We could publish those examples to Exchange and then bring them in just like we did with the patient data type as a fragment. These are considered fragments here as well. They are just in the file structure of our specification, and we are able to modify these. So we can modify these examples because they exist here, and we could have the data type here as well. But in our case, our data type exists in Exchange, and we pulled it in from someone else who created that. Okay, so there is the fragment usage and understanding of a fragment, and there are many types of fragments. In this case, we're just showing the data type fragment and the example fragment. Because if I were to add another example here, a new file, notice it's asking me for the different kind of fragment that it is. Trait, resource type, library, overlay, there's several different kinds. Okay, example being one of them, and that's what we created, was the example type. So back to our code and looking at our code, we've got, like I said, all of our query parameters defined here. And so when we go to use those query parameters, or I should say, we send in information for our query parameters, those query parameters, let me put a last name here so it makes sense. Okay, so in the case of this request, it would be under the GET, right? So it'd be a GET request. And I'm going to ask it to look for all of the patients with a matching last name. Okay, what if I just did a D? What if I can't really remember their last name and I want you to search for any of them? You know, you could set it up to where it would be forgiving and pull any of the last names with D. Now, all of that would have to be configured over here. It would have to be configured, and I don't have the right studio up that shows that first. Where is that one? Let me see. Yeah, there you go. Okay, I'll bring up another one to show you. So what we would do in this case is you would start working with and grabbing any of these attributes that were brought in that are query parameters. So these are query parameters that are going to be used in our application. So we're sending this information in as a query parameter. Okay, so then we would in turn, like in this case, showing an example, it's an unrelated flow, but you get the idea that the attribute that was just sent in here is being picked up in the flow and being used to set a variable to be used later in this flow in some way. like to go search the database. And we could search the database, querying it for that last name. Okay, so all of these are a query on the database, a query parameter. Okay, the other, as we send in the request, so all of this portion is part of a request, the request going in. Okay, the get request. And then we need to define the response. Okay, so this is ingoing. This is the definition of the response. And on a get request, so remember we're talking about a get request, we are going to define that the response is going to be an application JSON, the body of it. When it's a 200 success, the body is going to be an application JSON. It's going to be the data type patient. It's going to look like this. And in this case, because it's a get request, it's not an individual record coming back. We should be getting, I mean, if we do a query, we might get a single person. But if we query even on a date of birth, hey, there's a bunch of people that have the same date of birth, right? And then there's also Social Security should give you just one person. That's okay. But last name could generate multiple people. But either way, when we add the square brackets after our data type, then that tells our specification, that defines that it's going to be an array. More than one. It could be one or more than one. So it gives us that flexibility. So the response is going to come back as an array in this case, as an array, maybe an array of one. That's okay. But the query area is here. We manage it through this with a question mark. We pick it up in our application, setting it as a variable. There is the attributes query param. And then we would use that in this flow. Eventually, I'll have that other one built out as such, but you get the idea. Now, the other component is the URI parameter, okay? So let's look at the URI parameter now. And the URI parameter is our nested resource right over here. See our nested resource? We've got patients, and then we're telling it, okay, you're going to have, this is a URI parameter right there. The curly bracket, whatever you name it, and close the curly bracket, that is your URI. So when we send in, again, a URI parameter, what that's going to look like here is going to be / and some number. Okay. And then that number that we have there is going to be passed in. Do I have it in this one? I don't know that I have this one grabbing a URI parameter. Yeah, I did. I did the URI. Oh. Okay, so on this one, this is the URI parameter. And so in here, the friend identifier that I used in this example is using the attributes for the URI param. And this is what you're seeing here is best practices. When you have a query parameter or you have a URI parameter coming into your flows, you want to save them as variables fast because there are reasons that you can lose your attributes inside of your application. And that'll be part of that other video. And it's also part of this course material for this exam, which is a transport boundary. Okay. If you cross out of this, if you leave this flow to go to another flow or to a database or to a connector that makes you leave this flow to get data, your attributes are going to be gone. So if you needed that friend ID or you needed the querying details for anything else that was going to happen in this flow, they're gone. You better save them to a variable. Save them to a variable so you have them. Okay. So that's the URI parameter. All right. And the URI parameter, like I said, is going to be getting a specific record. Again, the request goes in. There's your request. It just goes in with a specific request of a certain ID, and you come back with a 200 with a single record. We did not expect or even have to put that it's going to be an array. It should be one. Now the post is a little different. So those are the gets. The post request requires us to send in information. Why? Because we're going to post data to, let's say, for example, the database. So if we look at a post, and in this post, we're going to be required to add a body. So this would be the body that is being defined here in a post. Okay, we're defining the body. And the patient no ID example. So when we do the post over here, we look at this post as an example and we do the try it. Here is the body that we would really be adding to our request, because this has to go in for our post to the database or to whatever we're sending in. So this would be in our payload. Okay, once this request comes in, this is going to be in our payload. So we've got to define that in our specification. So that's why in a post or a put or a patch, we have a body definition first for the request. In a get, you don't have that. But in a post, put, or patch, you have a definition of the body being sent in. And then we have the response that comes back after you successfully posted it. Now, there are times that we just get a message. It was successful. There's also logic that you can do that you get, you have it checked to give you a confirmation of what got posted. So you could actually ask it back for that confirmation from the database. So you would actually, the way that would look in your MuleFlow is, let me not mess with this one. Let me go back to the other workspace. We would have a insert, and then we would have a select. Okay. So that would be a different way of defining that. As soon as that comes up, I'll give you an example of that. So this is just a simple message that it was successful, but you could also have logic built into your MuleFlow, something like this. So let me create another flow real quick. You gonna do it? Come on. There we go. Okay, so to do something like a post, this will be a post patients. Okay, and we would link it up to the post that's over here, right? We would flow reference it over. And then in the database, we would do an insert. You could do a bulk insert or insert, but then we'd turn around and do another select. Okay, so the insert, well, actually what would really happen would a transform message would be coming in with our body. We would need to transform the data that just came in like this, and it would need to match the metadata data fields of our database. Okay, so we'd have to transform it and prepare it to be inserted to the database. See if it's going to grab it here. Yeah, it should. Let me save that. So how do we know how to prepare it for the database? We could look at, it's not populating it in yet. I could look at the select statement and look at the output. And this is why data sense is so helpful. These are the actual records, or I should say the actual field names of the records on the database. Data sense can tell that. When you've created your configuration for your global configuration and you test it and you get a successful connection, then it will in turn give you the data sense ability to see what these actual fields are called and their type. So I can tell I need to prepare this guy in this transform message because in my body coming in, I'm sending in this, and I need it to match exactly what the database needs for it to post. So there's a process there. Then once it's posted successfully, I can go back out and grab that one record by type, by the new ID number, and maybe return back. Instead of just a message, I could return back in my response down here. So requests going in would be the body. The response coming back could be confirmation with what I just posted. Okay. So if I wanted to, you could do that. You have that ability. All of that is done in the Mule app though. So even though we're defining our specifications here, the work is done in the Mule app. Sometimes people think just because we created in the specification doesn't mean it's a done deal. No, no, no. You got to go in and you've got to write and do your configurations in your Mule app itself to really pull all that together. Okay. So that's the parameters, query parameters, URI parameters, the requests, the responses. They're pretty standard in most cases. You know, like the patch, you would have the body defined. If it was put, you would define the body also. So anything needing to be added to a database is going to have a body of some sort. Now, where that shows up, I want to remind you of the Mule event that was shown in, I may have shut that other window down, where that guy had the design of it. Hang on a second, I'll bring this up. Is the Mule event. So remember our friend, the Mule event that gets created when a request comes in. We send in this request and guess what? This is created. Okay. We have a Mule event, right? That's created. If it's a GET request, payload's empty. But you have attributes. Actually, your attributes look like this. Okay. So you've got, you got a whole list. When you run this through debug mode, you're going to see all of these values. And it's a really good example to look at every processor and what is there, because you'll have attributes to a certain point. If you cross a transport boundary, guess what? This is gone. Okay, so we have attributes on a GET request immediately because it's all about the HTTP listener. Payload's empty. We go run our flow. And as we run our flow, then we get, when we do the GET request for the records, we now have a payload. The response that comes back is the result of that payload. Let me see if I can find one. There we go. The result of that payload, right? So we get the data back. Now on a post, put, or patch, we are providing that data going in. There's attributes. We're providing that data. It updates the database and comes back with some kind of response of whatever you want. Okay. If we set variables along the way, like we do, we want to grab those attributes, right? URI, the URI parameters and the query parameters, we want to grab them and put them as variables. So we have them. Even if we cross a transport boundary, it's okay. We have them saved as variables. And then we complete the process of the flow, and whatever is in the payload comes back in that response. And another thing, you won't see this on the MCD1 exam, but you will see it on the architect exams, is that if there are any errors are part of the Mule event. Okay, you'll see it later. It's not part of the scope for the MCD1. Okay. Any questions on requests, responses, query parameters, URI parameters?
No, I have all those memorized really well, I feel like, but I still want to look at that link because I like that way that guy was going into great detail on all of it. I'll definitely check this link out later.
Yeah, he includes methods that we don't ever talk about, the header.
That's okay.
And options, which is great. That's why I was like,
yeah.
Oh, he did a good job.
That's right.
On that.
Definitely look at that.
All right. Okay, so let's see. We are So again, the design, where we are in the life cycle, is just the design. We haven't done everything else yet, but the design helps you map out the rest. It helps you have a fix on what you're going to be designing, what you're going to be creating. Okay. So as we do that, as we go forward, then Mule project structure. Okay. This is the important part of this is that you can create a simple Mule app. Not a problem. You can do it. Let me close that. You can come out here and create a simple Mule app. It's good. Create a listener, create a flow. Simple, simple. Nothing here. Source main resources. Yeah, it's pretty basic, right? So you can do that. I mean, if you had to do just a simple app, you can do it. A simple Mule application, you can do it. However, the life cycle, or I should say, as we are going through creating a application in the dev environment, once we've completed that entire life cycle I showed you, then it gets, when we're satisfied with it and everything looks good, this whole life cycle here, when that's completed, then it needs to get promoted from dev. I mean, the whole purpose of it is not for it to just sit there in dev, in the dev environment. Oh no, it needs to be promoted into production. That's the whole purpose of all of this. So when we look at our, let's see if I can go to runtime manager. Okay. If we come into runtime manager and we have our applications and our API, our managed API, and it's secured with policies, and and I'll go further into client ID and client secret things later, but high level again, when we have this in dev, the goal is to promote it to the higher environments. Okay. So this one doesn't even have a test environment associated with it yet. So let me go create a test environment. So to go to your environments for your line of business, each line of business has different environments. Okay. I am working this in the dev IQ Developer Lab. That's the line of business that I'm in, is IQ Developer Lab. So in this one, there are only two environments. I've got dev and prod. I'm going to create another environment. Okay. By default, two are created, the design and a sandbox type environment. By default, those are the two created. I already added prod, and I changed the name of this one. It was called sandbox. I changed the name to dev. So I'm going to create another environment here, and this one's going to be test. Okay. Now, when I create an environment, there are three types of environments. A design type that's not in use any longer at this time, I should say. I don't know if they have a purpose for it later, but it used to do something else out of scope for what we need right now. But we are not using the design type environment at this time. Sandbox, which are all your lower environments. That would be dev, test, QA, whatever you want to call it. People call these environments different labels. I'm using kind of what I have always worked with, which is usually dev, test, prod. You can also add another one, dev, test, stage, and prod. So it depends on the company and the organization of what they want to call those different environments. But the lower environments, what I mean is not production. Production is like the ultimate. That is what the client's using in the real business processes. Everything below this is getting it ready to be promoted to production, to be really used. So that's why we call them sandbox. Okay. So the sandbox type test is what we're going to use. Now, production obviously would be for a production environment. In support for any issues in these environments. Like if I am working on something in Sandbox and in a Sandbox type environment, and you can have multiple, like you're going to see when I get this done, 2 Sandbox type and 1 production type. You can have multiple Sandbox types. That's fine. That's understood. But if I have an issue in one of them that I need to create a support ticket with MuleSoft, the Sandbox service level agreement is less, is less quick for them to respond because it's understood it's in a Sandbox environment. If there is an issue and you're telling them it's in a production environment, there is a service level agreement that's a faster response. Like some of them are even hours versus, a day or whatever. So it draws their attention and you have a faster response time on any issues. And it also shows that this is in full use at for the company. Okay, so Sandbox, these are all part of the maturity or growth of our entire API, our API environment as we promote it into each environment. So we start in dev or whatever you call it. I'm going to go with the labels that I'm familiar with. We start in dev, we build it out, we fully test it, and once we're happy in dev, it gets promoted to test. Okay. And once we fully tested it out there, it gets promoted to production or prod. So to create a proper application, we want to create one that's supportive of each of these environments. So I want you to think about that for a minute. Okay. Each of the environments have different credentials for the database, just even the database. The dev is going to use a dev database, like something that doesn't matter. The test environment is going to probably have a different database that is, more like the production one, more similar. And then the production database is going to be the real database. That's where real live patient data is. Okay. So each environment is going to have a different host name for the database, username and password for that database, any other connectors that we make. Like if we're connecting with another system, that other system is going to have a Sandbox environment and a real production environment. Okay, they're not going to let us dev and test around on a real live database. For example, when I shared with you Athena Healthcare and we were going to use those APIs, that's a developer API. That's not going to open me up to my real records. It's a fake database. There's a fake EHR, electronic health records, where it's going to be fake data because I'm in a sandbox. That's why they call it a sandbox. Kids play in dirt in a sandbox. It's safe. They can mess things up. But if it's a real production environment, now that's where I would have to have the real Athena client ID, client secret, real Athena credentials, because it's the production environment. It's my real records. Okay. So you're going to have different values in your Mule application in each of these environments. So when our Mule app gets sent even into dev, it should be equipped to handle all of those environments. Okay, you could do a simple Mule app, sure. But let me close this guy and open up the proper structure that you need to have for an application. Let me close this for right now. The proper structure to handle all of the other environments that it is going to experience in its future. So if I look at the config-dev file, the data here should be different in the other two. Now, I don't have other databases to work with. I've got one. But Ideally, I want you to be thinking about that this username and password would be different for these other environments. And you're seeing this hard-coded here. That's a big no-no. That would not be hard-coded just like that. It would be encrypted. That's for another, that's actually for the level 2 MCD too, is to do the encryption and stuff like that. Won't be covered in this in this review. So again, structure is very important when it comes to preparing our applications for their future environments. So that is a big portion of what you're seeing here, is each of these environments. Now, the other part is the structure of our XML files. Now, even in our case, we've got, this one is the interface and this one is the implementation. So this is my patient record interface. And then this one is the one that gets the database, and it's not complete. So I told you that already. Okay, so we have our interface on the left, and on the right, we have our actual interacting with the database. Okay, our implementation, interface, implementation. All right. Now, each of these flows, the more XML files you have, and believe me, sometimes you'll bring in I'll bring you in a example of a Mule application, and there's potentially like 10 XML files. I mean, we're working baby steps here. There is potentially multiple XML files. And if you go to supporting that, and you need to change a configuration on a global configuration, and they're buried in, who knows, you've got to go look through each of those XML files to try to find out where is that global element? Where is that global element? So you'll notice that the implementation, or the one that's getting the database information, there are no global elements here. Okay. But this one for the interface has the router. That is the only exception to allow, or I don't know, there might be another exception, but this is a exception of why you would leave the router in this XML, because this router configuration is unique for this flow, for this XML. So that is the one of the examples that you would leave a global configuration here. But all other global configurations are found in a global.xml file. Again, structure, best practices. Okay. And so I want to draw your attention to this global XML file, in which we add all of the global elements for all of the XML files, except for that router, in one place. So if I have to come in and I have to change something here, it is still just right here. I don't have to go looking through the other 10 XML files to try to find that global element. You structure it in one location. And so that's why we say structure is so important. Okay. The XML files are under source main Mule. That's where you're going to find your flows. That's where all your flows will be. Global configuration files are going to be in the global configuration file. Any of your connectors, any error handling things, that's another thing we'll cover over error handling. That is another thing that we will find in this global XML, would be global error handling. We'll go here. Okay, so we'll talk about that also when we get to error handling. So in the case of structure, this is the proper way to structure your Mule applications. Okay. So get into that routine. Get into that routine. Project structure is important. It is exam relevant. And then what we can see, we'll go look at this XML, this final step of reviewing the details here is, how does the mechanism know which configuration file to use? What is the mechanism that manages that? We have a global property called env. And this global property is originally set to dev. Now, sometimes you might see even an environment called local. That means you're going to run it locally. And there might be some different configurations, have been in the past when I've worked on some things, that the local, running it locally in Studio requires different port numbers, different things. So there might even be another configuration file that you would use called local. But whatever the value of env is what is going to point to the correct file over here. It is case sensitive. It does not matter what the real environment name is out there. It matters what these names are and that these match. So this is your mechanism. The $ curly bracket env is what's going to control which file it points to. And right now it's pointing to, because that env value is dev, it's pointing to this guy right here. Okay. And then when our application is in, let's say it's in Runtime Manager. And now what we want to do is we want to go ahead and promote it to a new environment. So I'm going to go to, this can be done through a pipeline. In most cases, it's done through a pipeline. And so what we would do is go to that new environment. To do it manually, go to that new environment and deploy an application and choose that file that's in Exchange. Okay, so I do let's see, EMS. If I could type S. And oh, I didn't deploy it through. Okay, it's not deployed there. I'll pick on this one for right now. Bear with me. But I'm going to pretend to promote this one. Okay. And what I would need to do, I'd name it something probably the same, but I would call it test. Okay. And I would put test. So I know what environment it's currently in, test, and I'd promote it. But right now, this env value is set to dev. So I'd come to properties here and I'd say env test. Okay. And now that will trigger that env value. And that env value would then be pointing to this configuration file. And you do that when you go to prod. You set that env value to prod. Okay. So that's the mechanism of how you would set up your application for the future environments, have your global elements all in one place, and how to override those property placeholders here. Okay. So that's how it works. And any questions?
Right now, that's making sense. I like the housekeeping where you're keeping up with your different properties, and those are always going to be in the source main resources. And that made sense. No questions really on that. I'm looking back at my notes.
All right, sounds good. Now, the other thing too is level 2, MCD 2, you'll get into the secured property placeholders. And that is going to involve encrypting some of that sensitive data. We're plain texting some of that stuff. That's a no-no, you know. And then there's also the ability to externalize or to bring in values from key stores. Like if I wanted to keep my production passwords safe in a key store, there's a way of populating that in securely as well. Not part of MCD1, but just so you know, it's part of future growth on that. Okay.
That makes sense.
Yeah. One of the things on flows and subflows is that sometimes people will take and use their specification and the flows here, they start just adding all their processors here. Okay. And that is not recommended to do. It's actually recommended to have them defined out separately, because that leaves your specification here and you are managing your flows in a separate XML. It's actually recommended to do that. Doesn't cost anything extra, doesn't take any extra time, but that will keep your specification categorized. And if you have to rescaffold or make any changes to your specification, it does not really impact the entire other flows that it's referencing to. Okay. Thought I'd better show that. All right. So that is a wrap for the day. If there's no questions, I'll go ahead and stop the recording.